Hello everyone and welcome back to Stationeers. Okay then, let's take a look. So we have a couple of items on our to-do list. We want to have a jetpack refill and we want to sort out water generation and store the generated oxygen. I think obviously for the best result we might want to store the oxygen first and then deal with the water generation. Especially since we have plenty of water that will come from the trader. Okay then, so first things first, let's just switch out the suit battery. And speaking of the suit, it has a bit of waste. And we can switch out the oxygen. And I will leave this one in the airlock for now. So you can go right here for the time being. Now, we did double our power generation and also, yes, I have been keeping an eye on the Discord patch notes, and there is an update in the beta branch, or maybe just internally, that will actually increase the power production of these guys. Basically, right now these guys can only go up to 500 watts, but later on I think they will be allowed to go even higher. I think maybe, I don't know, 800 watts or something like that. So for that one we have already too much power generation happening right now. So what we need to do is upgrade everything to big cables. Tell you what I will do. I will wait for the black hole to go down, and then I will pick up all of these cables that are on the power side. I will count how many of them there are, and I will replace them with heavy cables. By the way, I'll just print out a single heavy cable. Okay, 2 because of the half grams. And then maybe, can we automatically replace without having to pick them up first? So there we go. You come with me. Let me just switch out the wire cutters. So can I replace this one with this, for example? No, I cannot. We have to pick them up first. Okay then. So once we have darkness, I will pick every single one of the power side cables. I will count them, print out the required amount, and I will replace them. Hopefully I will not forget. I know I will, but who knows, maybe I won't. Anyways, as for the jetpack refill, I think we can do that one outside. It doesn't have to be done inside. Yeah, we don't need to waste space on that. So I think I will just simply, let me just take a look. Yeah, maybe we can put it over there somewhere next to the greenhouse. That should be alright. Now for that one, yes, as I've said a couple of times already, I have been watching Split C's last walk-on series, and in that one he had a small problem with overfilling a tank that was left outside. Basically, at night, cold gases were put inside as it cooled down, but at daytime it was heating up, and that caused it to overpressurize and it blew up. So let's try to prevent that from happening for us as well. For now, all we need is throw everything out of this printer, put it into the pipe bender, and we will need, let me see, we already have this utility kit. This one will give us a canister holder, so that's great. Then we will need one filtration unit, because obviously we do not want to put, for example, volatiles into our jetpack, because if we, for whatever reason, end up using the jetpack inside the base, then we do not want to release volatiles into the base. So there is that as well. Okay then, so we will also need one atmospherics unit so we can filter out the stuff. Let's start with that first. So atmospherics unit, just the one. And then I think we will need one, I think one pressure regulator should do it. Yeah, you know what? I think so. Basically, all we need to do is have a relatively spacious piece of pipe network, which will store the... I think I will go for... I believe we don't have nitrogen in the atmosphere, right? I think we can check from the inside. Do we have any pipes that are exposed to the outside? Ah, this one. Not room. There we go. CO2, volatiles, and pollutants. So, yeah. I think we will use CO2 as our propellant. We have no source of nitrogen, so that's going to be the easiest. So this will go outside. In fact, we don't need all this stuff to carry around. There we go. All this can go on the shelves. Ideally, we should use insulated pipes there. For the input, we can use these pipes. Also, we have only 3. We will need a bit more. Okay, then. There. I think, yeah, we can just have some extra... let's just use cowls once again. That's going to be perfectly fine. And one of these utility kits will go towards this canister holder. That will be enough of the cowls. Let's just start printing some pipes. So give me some of these, please. And then I think I will need 3 more utility kits. So 1 will go towards the canister holder, 2 will go towards the input pipe extension, and 2 more for the... you know what? Let's make it not 5, maybe 7. So we can increase the storage capacity of the actual pressurizing pipes. Okay, and 1 more, and half gram is no longer in the printer. That should be enough. So yeah, let's start printing some utility kits. Although, no wait, 5 of... 3 more of these, and 2 of the insulated type. Yeah, because obviously for the pressurizing pipe, we need to have insulated ones, just to be extra sure that we are not going to, well, heat up the pipe in daytime. So that is enough extra storage space for the input, 1 more for the output, and then utility case that is insulated. Give me 2 of these, please. Steel and silicon. Okay, I think we can eat now. So we have 3 more potatoes. Okay, cook 1 now, and then cook 1 after this one is finished. There, you come with us, you go inside. There, and... oh wait, did I put 2 of them inside? Well, those 2 potatoes were deleted. Not great, but not the end of the world. Okay, that's enough. Don't overprint. Okay, then eat, drink, and I think we can go outside. Also, don't forget... should we take care of the cables now? I think we can work on the refilling in the morning. Yeah. Oh, this can go here for now. Let's worry about the cables, because obviously we don't have any solar power coming in at night, so we need to do it now. Okay, then let's pick up all these cables. Ah, 50 exactly. Okay, then we need 48 more pieces of heavy cabling. That's going to be a lot. But I think the end result should be worth it, because obviously we don't want to overload these cables. So you can go on the shelf for now. And let's start printing. Also, yeah, I like the look of this power storage now. So anyways, all of you come outside. We will need the copper and the gold. We have plenty of those, so we should be able to print out all these heavy cables. So get started on that one, please. Okay, then you can turn off, and I think that's it. Okay, we can work on the refilling while we are waiting for the cables. All of you, please come with us, and you as well. Don't hide. In fact, you can merge with that one. And yeah, we can go. Okay, so, oh, you know what? I think I will take some frames with us because I suspect that we will need them. I think we can put this here. There. Oh, lovely. Okay. Well, I didn't count on this, but it should be fine. I can only hope that this one will go away by the morning. So, anyways, let me quickly... We don't have enough room. I think I will just place this one here for now. Yeah, it doesn't really need to be all that carefully placed. This is just for refilling our... whatchamacallit? Our jetpack. So filtration, filtered will go that way, unfiltered goes back out there. That should do it. Okay, you go there, and then we will have one for the input, one for the output, and then a little bit of this kind of action. There and there. Then some cowls so we can actually input and output. Good. Also, don't forget, pipes actually go... Oh, I already did. Okay. Next up, I believe it was first cables. And we don't have enough room. Okay, let's just go inside. We can drop down some of this stuff now. Okay, how is this? Almost there. 10 more. No, sorry, 8 more. Okay, so we will need these steel sheets to weld up the rest of the frames, and... Right, I think this will... Oh, right, almost forgot. We will also need a pressure regulator. And give me a regulator, please, for the gas pressure. So that is going to be iron, gold, copper. Okay, is this enough now? Yes, it is enough. You can stop. So that's all the 50 heavy cables. And then can you please give me the gold and the copper there and print me out a regulator, please. Okay, you can turn off now. Good, and I don't think we will need the regular pipes anymore, and the rest we will need. Okay, let's start wiring up because we are approaching daylight. So let's take care of the power generation first, and then we will worry about the rest afterwards. Hold on. That is one less cable than before. How come we didn't manage to put this together with the same number of cables? It was 50 cables, right? Or did I accidentally drop down one? Well, it's fine. It's not the end of the world. We can print out one more if we have to. But I could have sworn I had 50. Let me just double check. So this one appears to be just fine. These appear to be fine as well. Yeah. And the ones outside are also fine. Okay, fine. It will do. We just need one more heavy cable and that will do it. Okay, everything is back to normal, except now we are using heavy cables for the power side. So even if that new patch comes into the stable branch, these guys will not overload the network, so we are okay from now on. And you know what? Technically speaking, yes, now we can actually put down some wind turbines because they will be able to handle the load on these cables, but I will worry about that later. This is enough for now. Okay then, let's take care of the rest of this refilling for the jetpack. So first things first, let's just weld up these frames so we are not going to fall down. Good. And then we need 2 pieces of cable and the screwdriver there. So that's the filter. This will require a CO2 filter, and now we just need to sort out the actual filling side. So for that, let's just first place down the actual tank that will fill up. So this one, no. There we go, that will do. You can go right here. This is where we will put the tank that needs to be refilled, or the canister. Then we need a T-junction right here. Ideally, we should have plenty of... Oh, finally. Ideally, we should have plenty of volume in this pipe, so the refilling will go a bit faster. So this is where these will come into play. And can you please... There we go. You can go right here, it's fine. Another T-junction. There, and then... You know what? We don't really need a T-junction. Yeah, you know what? Let's just have this one go into a turn like that, and this one will go upwards like that. Sure. Now, what side is the regulator's power connection is? So we want to go there and upwards. I was afraid of this. You can go this way, I suppose, so we can access the power cables. This is why I wish we could change the side of these power connections. It can be a little bit annoying if I'm completely honest. Anyways, for this one, on this side we don't need insulated pipes, but it's fine. And a cowl for the output. There. And now, what kind of pressures do we want to maintain in this one? I think... we definitely don't want to overpressurize on this, so let's just go for 5 megapascals, just to be on the safe side. Sure. Okay, and at this point, we just need to cable it up, and this is good to go. Also, close all this. Okay, so theoretically we only need to hook up one more piece of cable, which should be under this wall. So it is safe to break open. Yes, it is safe to break open. So we don't need this wall here right now. You can go away. There we go. And we also need the angle grinder there. Okay, so you can combine here. And you can combine here. So, as I said, we are still missing a single piece of cabling right there. Okay, so you can go... Do we need the wire cutters for that one? Why? Oh, right. Technically speaking, yeah, that is a turn going into the AC, sorry, the filtration unit. So, we need the wire cutters, and there we go. So now, theoretically, everything is hooked up. Okay, so can you please give me... should we go for a big filter? Sure, medium filter it is. So, iron, a constant, I believe, and silver, right? Yeah. Okay, just one of these will do. So, if... you know what? Yes, I will actually automate this. So for that one, we will need an IC chip. So all of you, please go inside. You come with us. Please give me everything you have. I believe we will need iron. What else? Oh, right, steel, definitely. But first, no, don't open, just turn on. So an IC10 chip. Yeah, steel. Okay, one of these, please. And we can operate this one right from the filtration unit. So what do we want? We want to check the output pressure of the filtration unit and don't go over 5 megapascals, just to be on the safe side. And if we go, you know what? Yeah, if the pressure in the pipe goes above, let's say 7500, then we will turn on the regulator. So we will need one pin on the AC unit. So you go in there, give me the programming IC housing import. It should be empty. It is. Let's do it. Give me a second, please. Okay, is this going to be okay? So basically, we will load into the output pressure register the output pressure of the filtration unit. If it is less than 5000, then we will trigger the minimum pressure, which will turn on the filtration unit, so it will start filling up. As soon as it goes above 5000, oh, right, you know what? I think we need the temperature as well, because we don't want to use hot daytime gases for this. We want to go for cool nighttime gases. So, right. Okay, small change. So we will check if the pressure, also, yeah, we will load the current temperature of the pressure, the input temperature from the filtration unit. So if the minimum pressure is 5000, so basically the pressure inside the output is 5000, then this one will be set to 1. And all right, we want to check the temperature. So we want to set less than, I suppose we can override the temp with this. It's going to be okay. So temp override this one. If the temperature is less than the current value of the temperature is 333, I believe this is the 140, right? Yeah, that sounds like it. So if the outside temperature is less than 140 degrees Celsius, then this temp will be set to 1. If it's higher than that, then it will be 0. If both of these are true, then the filter on-off will be set to 1. If any of them are 0, then it will be set to 0, and that will control the mode of the filtration. And for the regulator, we are only interested in the max pressure in the output pressure reading on the filtration. If it goes above 7500, turn on the regulator. Right. I think this will work, right? Let's take a look. Confirm. Programming IC housing, export. You come with us and you can turn off. So we just need to set the right. Okay, I think we have everything. Now, I obviously want to make sure that we are naming the regulator because we have plenty of devices on this network now. So you are going to be our Jetpack refill, not refill pressure regulator. Confirm. And you are set to, you know what, let's just set this to 7500. This should prevent it from going above this. And this is still safe pressure. Okay, so we need to set one pin on this device 0. TB will be for the filtration. So you are the Jetpack refill. Oh, there we go. Jetpack refill pressure regulator. In you go and turn on. So you are now idle, right? Yes, because of the temperature in here is too high. As soon as this one drops below safe levels, which should be fairly soon, then you will start pressurizing. And before we get to that, let's just have one extra tank on standby. Because, well, it would be nice to have one tank immediately available by the time we actually need it. So give me iron, please. Yeah, you know what? I think I placed this one a little bit too close to the base walls. So if this one blows up, we are in very, very big trouble. But I think it should be safe. So you come with us. Turn off, close, and there we go. You go in here. Oh, no, don't throw it out there. Can you please give me a canister? There we go. We only have a white paint. Do we want to have? Yeah, we do. Okay, can you can close now. Can you, tool printer, can you please give me a... I mean, if we are going to use CO2, it should be gray instead of green. In fact, I will repaint this one as well. So can you please give me spray can for gray? Just the one. And there we go. You can close now. You can come with us. And that's it. Okay. Obviously, want to do this outside because using the spray cans will release pollutants. So at this point, you can go... No. You can go on the floor. You can repaint it now. In fact, you can repaint this one as well. There we go. No, don't drop it. Just stow it away. So, you guys come with us. So you are active now, right? Idle still. Okay, I think I messed something up. Oh, right, no filtration unit in this one. Just put this one in there. And you are still idle. Oh, wait, did you overpressurize already? With unwanted gases? No. Okay, let me quickly name this one. So this is our Jetpack refill filtration. In fact, while I still have it on my mind, this is the coolant refill filtration. There we go. Finally, I managed to do it. Anyways, what did I mess up? Let's take a look. Because I absolutely messed up something. So you turn on. we are looking for the Jetpack refill filtration import. There we go. Let's take a look. So let's run through this one again. Load the pressure output from the filtration. We are interested in the filtered output, so pressure output 1. Output pressure register, that's correct. Then we want to load the temperature of the input side into this one. Should we just, I mean, if we override this, it should be okay. So I don't think we need to worry about that. The temperature is 313. Let me just double check on the calculator to be extra sure. So 273 plus 140. Oh, sorry, 413. That's the problem. There we go. Now it should be okay. Confirm. And Jetpack refills filtration export. Now it should be active, right? Let's take a look. Oh yeah, by the way, what is the status of the whatchamacallit, the volatiles? 1 kilomole. Nice, but we can do a bit better than this. So anyways, this one should be active now, and it is very much active. Good. In fact, I think this little coding problem was a small blessing in disguise, because I didn't have the filter on before, so that would have filled this place up with unwanted gases, I think. Anyways, you are filling up with nice cold CO2, and we have plenty of volume in this pipe, so that is why we have, you know, so slow filling. That's fine. Start filling up this one, please. Okay, and by the time this one fills up, we will run out of CO2 in, propellant in this one, and we will be just fine. So, and this one should be okay for the regulation of the, but you know what? It is very, very sensitive placement, so let's just double check. Yes, I suppose I could move it a bit further away, but let's just check. So, I only reached this place in the code, so then we will check. The minimum pressure we want to have in there is 5 megapascals. So that is, if the output pressure is less than 5000, then this will be 1. Then we don't want to go above 7500. So if the output pressure is above this, then we will set the max pressure to be 1. And then if the minimum pressure and the temperature are both acceptable, then the filter on-off variable will be set to 1, and that is what controlling the filtration unit's mode, which is the active or inactive. And the max pressure will determine whether or not the regulator is on. Right now it is not overpressurized, so it is off, so that is correct. Okay, I think this should be safe. Right. At least as far as I can tell. So basically, if for whatever reason it gets overpressurized, for example, we put in 5 megapascals of pressure into that canister, but in the midday heat it heats up more than usual, and it expands the gases inside, it will overpressurize, and hopefully this safety mechanism will prevent that from exploding. Okay, then you can go there. We don't need the pipes anymore, and there we go. Okay, so right, we are okay, fine. Let's just strip down, and we can take off the Jetpack refill from the to-do list. So that's fine now. Next up, as I said, I think we need to take care of the oxygen storage first, because, well, we need to store the oxygen to use it, so that one comes first. So once again, we need a another filtration unit. I think I will put it here. So we need to expand this platform a little bit more. That's fine. We will have a small vent right under there, hidden. and we will have a gas sensor inside. Then we will check if the pressure is above, let's say, 90 kilopascals, and if the ratio of oxygen is, let's say, I don't know, 20%, then we can start siphoning off the oxygen from the base. And then we will also need to regulate the pressure in the storage, so we will have a pressure regulator, and that pressure regulator will actually go to a nice long chimney, which will basically flare off the excess oxygen, but I don't think we are in danger of reaching that point anytime soon, so that's fine. Okay then, so for this one we will need a nice big tank. So this one and the steel, there you are. First let's make a nice big storage tank. So tank and an insulated one obviously, and we also need copper. You come with us as well. In fact, let's just put everything in here. You empty out. You are empty already, that's good. So, you, give me one insulated tank. Iron is in here. There we go. So, one tank, and then we will need one filtration unit. So, Atmo. And then that's fine. And then don't forget we need one regulator, one pressure regulator, and we will need the pipes, these pipes, and some cabling as well. This CO2 filter is 1%. I think I will just recycle it. I will not use it for anything. And right. So you come with us. For the flare, we will need one more cowl. Just the one. And then for the intake, we will need one passive vent. There, and what else? We will not... you know what? Yeah, two passive vents. Combine them together, please. Because we don't want to waste the excess gases, so one vent will be for the input of the filtration unit, and then another pipe will be coming back inside and basically vent back the nitrogen and the CO2 back into the base. So that's fine. What else? We have plenty of pipes. Now we just need a small platform and the steel sheets. And I think that's it. Also power-wise, still not the best, but it's better than it was before. I think over time this will reach high enough levels. So anyways, yeah, you know what? Empty out, give me one more frame. So for that one we need steel. There you are. You can turn off. Give me one more frame. Just the one. So we have pipes, we have insulated pipes, regulator, tank. Oh wait, regulator, I didn't print it. No, I did not. Okay. That needs to be remedied right now. So can you please give me a regulator? Okay, so you go on the stack. Okay, I mean... it's fine. So you come with us. And we did have a small storm recently, so I think we can manage for a little bit longer. Yeah, we don't need to worry about storms for a little bit. So you and you and you. You know what? No, let's eat before we go. So yes, I did waste some of the potatoes. We need to harvest now. So this is our first proper harvest of potatoes from the greenhouse. So you come with us and replant one, and we will cook one. And there we go. That will do quite nicely. Now we are no longer in danger of putting too many food into the microwave. Okay, let's go for it. So, visor down, cycle, and off we go. Let me just quickly check this one. So, you go there, you go in the hand, and right, this is nowhere near the point where it could actually, you know, overpressurize, but yeah, it's okay. And it is idle, so that's good. Okay, then first, let's place down these 2 frames. So you will fill up this space there, and then the... Okay, fine. Let's switch out. Oh wait, this waste tank is already full. Okay, then let's quickly weld these up. We need to go back inside and vent out the waste tanks. So, let's take a look. I think, yeah, get used to seeing doors like this. Unfortunately, you know, the doors actually had to go somewhere and they will clip out through the walls. But anyways, so we will have, yeah, insulated pipes go through here. So I think this is going to be the return pipe. This is going to be the input pipe, and then we need the atmospheric skid. This is going to be a filtration unit. Ooh, that, you know what, in that case I think this way is going to be best. Right, so input pipe and then the unfiltered waste pipe. This is going to be oxygen, CO2 and nitrogen. This is going to be just CO2 and nitrogen. Oxygen will be taken off from the input pipe. There, I will put down the passive filters once we go back inside. Yes, I can actually do it like this, but I know some people don't like it, so I will try to limit that as much as I can. Then pipes, and then that and that. Oh, sorry. Screwdriver. There we go. Alright, I forgot to make another filter, but that's fine. We can make some more. And then we need to actually store the oxygen. And yeah, I didn't leave enough space. Because of these guys, we need to make one more frame. But for now, I'll just put this guy here. So you will go here. There we go. This is what will store the oxygen. But as I said, we want to make sure that we are not going to overpressurize this. So let's have a pressure regulator exactly right there. But this one needs to be a back pressure regulator because we need to maintain the pressure behind it. So there. And obviously all this will be nice and insulated, so we are not going to heat up the pipes or the oxygen. So there, and there, and there. Okay, and now we just need a nice long pipe. So as I said, I don't think we are in danger of overpressurizing this much tank because the oxygen generation is going to be super slow, but it never hurts to be prepared for every eventuality. So let's just make sure we are, you know, not overpressurizing our only source of oxygen. There. And in case we ever build up enough pressure in here, then basically we'll just flare off the excess oxygen. If we have so much oxygen that this is full, then wasting a little bit is not going to be a big problem. There we go. And the cowl goes right on top. Oh, Jetpack critical and a new achievement. Okay then. Good to know. So, anyways, power. Can we route this power? Yes, we can route the power right under the walls. Okay, we'll continue on the inside. And now we just need first name these guys. So you are going to be the oxygen storage back pressure regulator. Okay, and now we need an oxygen filter and hook up everything and we are good to go. Okay, let's go. So don't forget the two passive vents, the power connection, and we are done. Now, obviously, we were not able to do the water generation in this episode. That's going to be a whole other thing, but at least we managed to take care of two things, the jetpack and the oxygen. So first things first, let's take care of the power. So you will need to go all through this way, and which is going to be the fastest, I think, through here. Can we place? No, we cannot. In that case, need to go here. So that's good. Then the two passive vents. So this is the return pipe. And this is the oxygen filtration pipe. Can I please? There we go. Okay, everything is insulated, so heat should not leak into the base. These passive vents are on frames, so they will not radiate heat. So I think we are okay on that. Okay, now we just need a single oxygen filter and we are good to go. Right, silver and constant temp, please. So let's just make nice medium filters so they will last a little bit longer. So oxygen, medium filter, please. Just the one for now. I mean, ideally, maybe we should print two. Yeah, we can afford it, it's fine. At some point, we definitely want to set up some kind of warning system for the filters running out. In the last game, I did set one up, but I don't remember how it worked, so we need to basically read the contents of the slots on the filtration units and determine just how full or unfull they are and stuff like that. It is a bit complicated, but not unmanageable, basically. And also, take a look at these batteries. Aren't they lovely? Wait, they charged a lot. Does that mean that we are overpressurizing the volatiles?
Low pressure. Oxygen critical. Pressure
Oh, excuse me?
Low pressure.
Why?
Oxygen critical. Pressure critical.
What's happening?
Cognition low. Low pressure.
Excuse me, what happened? Oh, oxygen filter goes into the suit. Don't do that, please. Alright. Let's just print out a CO2 filter so this one doesn't happen anymore. Okay, mystery solved. Can you please give me a carbon dioxide filter here? Yeah. A small word of warning. Always have these slots on the suit filled up, so, you know, this doesn't happen to you. Just the one filter will do, please. Thank you, and now if I stow, this will go in the suit, and that is correct. Okay, thankfully I didn't damage our lungs too badly, so I think we should be okay. Should we set up the code now? I mean, we might as well. No, don't empty this. Empty this. So we need copper, gold, iron, I believe solder as well, and steel, I believe. So for the IC10 chip, electrum as well, and the steel. Where is the steel? So it's not in here. Where did I put the steel? There you are. Okay, one IC10 chip, please. And I did name this one already, right? So this is the oxygen storage filtration. Import, it is empty. Good. While this one is printing, might as well take care of the code. So let me see. Ooh, okay, this might be the most complicated code that we have written for this playthrough at least. So let's take a look. We are working with 3 different variables. So we need the oxygen ratio in the base, the ratio oxygen input. And then we are also interested in the pressure of the base, so pressure input from the filtration unit obviously. And we also need to know the output pressure, so the pressure output variable goes into the storage pressure register. And then first I want to check for overpressurization, because later in the code we will override these variables or registers. So if the pressure in the output, basically in the storage, is 55 megapascals, then the regulator on off will be set to 1. If it is not, then it will be set to 0, and that will control the on variable on the regulator. And then we will continue. Basically, if this is true, then all this will be completely disregarded, because one of them will come back as untrue, but you know, it will still run through it, but it will do nothing. But in case this is not true, then the regulator will not turn on anyways, so it's not relevant, so we can continue with the code. Then we will overwrite the base ratio, oxygen ratio register if the actual ratio is 20%, so 0.2. If it is, then this will suddenly become 1. And then we will override the base pressure, because yeah, I think at this time I will start recycling registers instead of designating new ones. So we will override the base pressure register if the old base pressure register value is 90. So basically, if the pressure in the base is 90 kilopascals, then this will be set to 1. And then we'll check if the pressure in the storage is less than 50 megapascals, so 5 whole megapascals less than the absolute maximum that we can go for, then the storage pressure variable will be set to 1. And then we will check all 3 of them. And we'll use this filter on-off register. First, we will check if the base O2 ratio and the base pressure registers are 1. And if both of them are 1, then the filter on-off will be set to 1. So we are already 2/3 of the way through the checks. So next up, we will override this on-off once again. And if the first 2 checks have came back as true, then this one will be 1. And we will check it against the storage pressure. If it is below 50 megapascals, then both of them will be 1. So this will remain 1. If this one is not true, basically if the pressure is between 50 and 55 megapascals, then it will be set to 0. And then we will use that to set the mode on the filtration unit. I can only hope, fingers crossed, this should work, right? I think so. Confirm. Okay. For now, let's just use the programming IC housing, because we have everything in here. So it is almost finished printing. We will write the code and we will go outside. but as far as I can tell, it should work perfectly fine. So right now, the pressure in the base is 100 kilopascals and the oxygen ratio is 45. So if we go outside, this should turn on the filtration unit. So programming IC housing export, and we have the code on the chip. We can go outside. Okay, so you know what? You can turn off and you can turn off. Don't waste power. Although we are doing quite okay on power. So before we go to the filtration unit, let me just check the volatiles. We built up so much power that I suspect that we might have filled this one up already. Almost. Okay, before we go, let me quickly sell all these volatiles. So, you, my friend, can you please buy all these volatiles? That's going to be 50 money for us. And that's going to be 45 more. And I think we are done. Close, don't depart. How are we on the pressure in this pipe? It is empty now, basically. Okay, we don't have enough volatiles, so you turn off and just empty this one out. I don't want this one to overheat at the daytime. Okay, that's good enough. You can turn off and you can keep on filling. Exactly. Okay. Right. How is the CO2 in the, whatchamacallit, the jetpack? It is almost up to pressure, so tell you what, we can switch these out. So this is pure CO2. This one still has, you know, it's fine. Just switch them out. This one will be a mix of nitrogen and CO2. Okay, so the jetpack is refilled. Now you. So if all goes well, oxygen filters on go first, because we don't want to filter any unwanted gases, although it wouldn't be a big problem, but still. So you, chip goes in, and there you are. We need to set the regulator as well, so I did name this one, yes, oxygen storage back pressure regulator. So you need to be set, let me see, right here. Oxygen storage back pressure regulator, exactly. Okay, so theoretically, if I turn this on, then this is going to be active. And it is. Very good. So now we are siphoning off the Atmo in the base, and we will only leave a 20% of oxygen in the base. Right. So let me just take a look, and where is it? Right in the other hand. Yeah, very good. We are very, very slowly filling this tank up with nice pure oxygen. Okay, yeah, technically speaking, I should paint all this to white. These are fine as they are. Yeah, you know what, might as well. We had quite a bit of coding in this episode, so I think we can run a little bit longer. Although, technically speaking, the recording is at 1 hour and 12 minutes now. But I think it's going to be okay. So please give me the white spray can. And I will paint that one because that is our oxygen storage tank. In fact, I really should name it as well, even though it is not on the network, but still might as well. So you are the oxygen mode tank. Okay, so you are going to be white, and all these pipes can be white. And there we go. In fact, that filtration unit should be gray and stuff like that, but that's a lot of repainting. Okay, let's go inside. Let's make sure we don't cook, and I think we can call this episode right around here. So, we managed to sort out the oxygen filtration from the base. So right now the pressure in the base is still high, but it is approaching the 90 kilopascal limit. Once that one is reached, that guy should go idle. And we don't really need to worry about the temperature, although just to make myself feel better, I might want to set up an AC unit out there to make sure that the oxygen in there is cooled to maybe, I don't know, 20 C. Anyways, let me quickly switch out this stuff in the suit. So oxygen, we can vent out the waste a bit more, please. There we go. And the suit can go in the airlock. So there you go. Right. So I think in the next episode we will try to take care of the water generation. That might be a bit tricky, but I think we will be able to do it. The problem with water generation is that, well, that will come out as super hot water. Basically superheated steam, because we are going to burn hydrogen with oxygen, and that will give us the water. And yeah, that's going to be super hot, so we need to cool that one down. So I think first I will radiate, or should we just go for AC units immediately? Or maybe we can use phase change too. That would be kind of interesting. Also, you know what? Let's just have one potato at the ready in the microwave. I am not sure if I will use phase change because that is very, very complicated. And I think I might be able to explain it, but I am not 100% sure if I will be able to. So we might still resort to using just AC units. I guess we will decide later. For now, all that is left to say is that thank you for watching. If you liked the video, you can leave a like, leave a comment, and maybe subscribe to the channel if you want. If you would like to support me a little bit more, you can do so by clicking the join button and becoming a channel member, which will give you an early and ad-free access to these videos. Once again, thank you for watching and thank you very much for your support. I will see you in the next one. Thank you and goodbye.